Section 5.3, inequalities in one triangle. So first of all, before I even talk about inequalities, let's look at something that's actually equal. And I'll show you how that's going to relate to inequalities and to triangles. I think you would agree with this, that 5 is equal to 2 plus 3. What I want you to see, though, is this. Anytime that I add up two numbers, let's say this, if they're positive numbers, okay, because negative numbers would be different. But let's say anytime I take two positive numbers, add them together, and I get an answer, I get a sum right here, this answer, this sum, is going to be larger than either one of these things that were added together. So for instance, if 5 is equal to 2 plus 3, that means that 5 is going to be greater than 2, and 5 is also going to be greater than 3. Let's write that out. That's the greater than symbol. Let's make it look a little bit better. There we go. 5 is greater than 2. And what else could I say about this? I could also say that 5 is greater than 3. Anytime you have two numbers together, if you took two numbers and added them to get this number, this has to be bigger. This has to be bigger than either one of these. Not just one of them, but both of them. So that's true about regular numbers. That's also going to be true about triangles. And we're going to look at that right now. So let's draw us a triangle. This triangle you should recognize. All right, you've seen that before. It wasn't too long ago where we did something like this. And let's just name the angles right here. We'll call this angle 1, we'll call this angle 2, and we'll call this one angle 3. Let's get rid of that little dot. Where'd that come from? Okay, so what we're going to do is this. It's a theorem, and I'll even write down the name of the theorem for you. It's called the exterior, all right, because we've got an exterior angle, angle inequality. The exterior angle inequality. All right, we probably won't refer to it as this name, but it's nice to stick the name up here so you can see what's going on. All right, scooch this up a little bit. All right, so the exterior angle theorem, what's it saying? It's saying this. Now remember when we had the exterior angle, what was true about this exterior angle? Well, the exterior angle is equal to the sum of the two remote interior angles. We've discussed that before. So angle 2 and angle 3 would be the remote interior angles. So we knew from another theorem that angle 1 is equal to angle 2 plus angle 3. Just like we had up here with our regular numbers, the same thing works with the angles. So if angle 1 is equal to 2 and 3 being added together, guess what must be true about angle 1? Well, angle 1 must be larger than angle 2, and angle 1 must also be larger than angle 3. So if I just gave you this situation, and I didn't tell you any of the values for angle 1, angle 2, or angle 3, I didn't tell you any of the measures of those angles, you could look at this and you could say that angle 1 is going to be larger than angle 2 without even knowing any of these numbers. And you could also say that angle 1 is also going to be greater than or larger than angle 3. So let's write that down. So we could say that angle 1 is greater than, sometimes it's easy to get confused between the angle symbol and the greater than and less than symbol. So I made that a little bit bigger than I normally would. So I could say that angle 1 is greater than angle 2. And I could also say that angle 1 has got to be greater than angle 3. So that's a pretty important thing, and that's kind of stuff they're going to ask you on some of these problems. They're going to ask you the relationship. When they ask you the relationship, they want to know, are they equal to each other? Is one bigger than the other? Is one smaller than the other? And that's what they're asking when they say, what is the relationship between these angles? So angle 1 would be greater than angle 2. Angle 1 would be greater than angle 3. Now that doesn't really tell me anything about 2 and 3. Just from this information, I don't really know if 2 is bigger than 3 or 2 is smaller than 3. But I do know that 1 is bigger than 2. I could write it the other way. I could compare angle 2 to angle 1. So I could say that angle 2 would be what? Less than angle 1. It's basically saying the same thing as we did right here. You could also say that angle 3 would be less than angle 1. Okay? Let's move on to something else. Well, before we move on to the next thing, I rethought this and I looked in the book and we have this nice example here. And you're going to have a few problems that you're going to have to do something like this. So I thought we would do this example. So let's do it real quick. The question says, using the exterior angle inequality theorem, the thing we just talked about, list all the angles that have a measure less than angle 7. So I'll just write it out. Less than angle 7. So I want to find out. Now, they didn't give me any values, any measures of these angles. Okay, they didn't say this is like 30 degrees or this is 100 degrees or anything like that. You just have to go by that exterior angle theorem or inequality theorem to figure out what is less than 7. So let's just put an arc around this just so we can see which one we're talking about. Now remember, the exterior angle is going to be greater than either one of the remote interior angles. So 7 has to be bigger than, look at this triangle right here, MKL. See this triangle right here? So this is an exterior angle to this triangle right here. So that must mean that 7 has to be bigger than 5 and 7 has to be bigger than 4. What we want to do is we want to find all the angles that are less than 7. Well, 7's bigger than these, so that must mean that this little angle right here, tell you what, we'll mark these little ones in blue, right? Now, I'm going to mark one arc for each of these. It doesn't mean these two angles are equal to each other. I'm just doing it so I can highlight which one. I tell you what, I'm not even going to put the arcs. Let's just circle it. So which angles are less than 7? Well, 5 has to be less than 7, and 4 has to be less than 7. Why? Because 7's bigger than 5, and 7's bigger than 4 because of the exterior angle theorem. All right, so we know so far that we got angle 4 and angle 5. What else do we have? Remember, we can only use this when it's an exterior angle, but this is also an exterior angle to another triangle. Do you see the other triangle? See this big triangle right here? JKL. See that big old hunkin' triangle right there? This is also an exterior angle to that big triangle. So check this out. So angle 7 must be larger than either one of the remote interior angles. So which ones are the remote interior angles? Well, angle 1 is a remote interior angle. So 7's got to be bigger than 1, which means 1 has to be less than 7. And that's what we're trying to find. We're trying to find all the values that are less than angle 7. So angle 1 has to be less than angle 7. Well, what else has to be less than angle 7? Well, look, this whole big angle right there has to be less than angle 7. Right? Do I just look at it? Do I just eyeball it and say, well, yeah, that looks like it's smaller than 7? No, that's not what we're trying to do here. We're going exactly by the theorem. So remember, this whole entire angle, this combination of 2 and 4, have to be less than angle 7. So guess what? If 2 plus 4 is less than 7, guess what's true about angle 2? Angle 2 must have to be less than 7 as well. Right? 2 and 4 have to be less than 7 because the whole entire angle is less than 7. So the angles that make up the big angle have to be less than 7. And there you go. Those are your angles that are less than angle 7. So I would list them. I would say angle 1, angle 2, angle 4, and angle 5. Because of the exterior angle inequality theorem, all of those will be less than angle 7. Okay, now we're going to go to something a little bit different. We're going to talk about a triangle again, but watch what I'm going to do. I'm going to draw, you can draw any triangle, but I think this works better if I have an obtuse triangle, all right? So I made a nice obtuse triangle right here. You could use any triangle, right triangle and acute, doesn't matter. I just decided to use obtuse. What this theorem is basically saying, let's name this ABC. All right, so I've got a triangle ABC. What I'm going to do is I'm going to compare the sides. So for instance, if I had, let's just make up some angles here. If I said this was, I don't know, 130 degrees. All right, so if this is 130, the whole thing is 180. So these two have to add up to 50. Let's call this 20 degrees and let's call this 30 degrees. All right, I'm just making these things up. Now, what this theorem says, and they don't really give it a real nice name. They call it the angle-side relationship in a triangle. It's on the top of page 344. Page 344. They could probably think of a better name for that theorem than this, but that's what they call it. I'm not even going to write that down. Let's just understand how it works. It's actually very, very simple. And what we have is this. If I know the angles of the triangle, I can tell you without knowing any of the lengths of the sides, which side is the longest side, which side is the shortest side, and which side might go in between the two. And I can know that by knowing how big the angles are. So watch this one. This one is the largest angle right here. So that means, this is what the theorem tells us, okay? knowing the largest angle, I can figure out what the largest side is. And so what I do is I just look across or opposite the largest angle. So I look for the largest angle and I look opposite. That side right there, AC, that side is opposite 130. So if this is the largest angle, guess what the largest side is? AC is the largest side. And so what they're going to do is they're going to ask you to list in order. Okay, list. Most of the time it seems like they do it like this. List from smallest to largest. Smallest to largest. Okay, so we're going to list the what? Let's list the sides from the smallest to the largest. They already told me the angle, so that's not that big of a deal. I want to find the sides from smallest to largest. Well, that's the largest angle. So which, or not angle, but side. That's the largest side. Which one do you think the smallest side is? If the biggest side is opposite the biggest angle, guess what? That's right. Here's the smallest angle. Guess which one is the smallest side? The one that's opposite. You see that? See, this side is opposite this angle right here. So this is the smallest side. So BC is the smallest side. So you know what I could do? I don't even need to write that AC and BC because we already see from the triangle. I could just say this is the largest side and this is the what? Smallest side. And what do we call the one that's in the middle? The book doesn't do this, but I'll just call it the middle one. All right, the middle length, I guess. All right, we got the smallest, the largest, and the one that's in the middle or between, whatever you want to call it. The medium. Let's call it medium instead of the middle because middle has a connotation. I'll just say it's the medium length one. Okay, the one that's in between the smallest and the largest. All right, that's a lot of talk to say what? If this is the largest angle, the side opposite is the largest side. If this is the smallest angle, the side opposite that one is the smallest side. And it works in converse as well. If I knew that this was the largest side, for instance, let's draw one. And we'll just make up a triangle here. It doesn't have to be obtuse, but it seems like I always do that. I'm just making up numbers here. Let's say this is 5. And let's say this is, I don't know, 3. And let's say this is 7. That's good enough. I don't know if that really works for this, but it's close enough. What if I had this situation right here? And that's what I knew about this triangle. I knew the lengths of those sides. They're going to ask you to list, okay, to list from the smallest to the largest the angles. List the angles, okay, from the smallest to the largest. So let's do this. Let's call this X, Y, Z. All right. So the converse is true as well. If I know the largest side, guess which one is the largest angle? Well, it's the one that's opposite. So if that's the largest angle, which one's the smallest angle? Well, you look for the smallest side. 7, 5, and 3. Which one's the smallest? 3 is. So what angle is opposite the 3? This angle right there. So which one's the smallest one? Angle X is the smallest one. And which one is the medium one? All right, well, 5 is the medium side, so guess what? This angle right here, Z, is the medium angle. And then which one is the largest angle? Well, it's opposite the largest side, so this would be angle Y. Hope that makes sense. All right, so if I know the largest side, I know the largest angle. If I know the smallest side, I know the smallest angle. It's just opposite each other. That's all you got to know. Pretty simple. Let me just cover one more thing really quick. What if we had a right triangle? I know we've been doing obtuse triangles. What if we had a right triangle? I don't know if you were ever taught this, but when you have a right triangle, and we'll have a whole entire chapter later on in this book about right triangles, a whole entire chapter just on right triangles. Okay, but for right now, this is probably something that you had learned before. If you have a right triangle, this side that's opposite the right angle has a special name, and we call that the hypotenuse. You might have heard that before. All right, so that side right there would be the hypotenuse. Now, a lot of teachers, even when you're younger, they teach you something about the hypotenuse. The hypotenuse is always going to be the longest side of a right triangle. But we can see now why it's the longest side of a right triangle. Because hypotenuse, by definition, is always opposite the right angle, the 90-degree angle. And guess what's true about the right angle in a right triangle? It's always the largest angle. All right? You can't have another obtuse in a right. You can't have another right. This always is the largest angle. So guess what? If the hypotenuse is opposite the largest angle, the hypotenuse is always the largest side. So that's kind of a nice little side to what we've been doing. And why is that true? It's because of that theorem. Again, they call it the angle-side relationship in triangles. At least this book does. Okay, different books call it different things. Another book might give it a better name than that. But that's basically all it is. So look at that. I kept this under 20 minutes. It's only 15 minutes and so you should be happy about that. And good luck on this lesson when you do it. And we'll talk to you later. Bye.